if you want to skip it. So let's just assume you have now seen my video on reminders about doing basic integrals, and now we're going to do an example. Let's say that a mouse is pushing a piece of cheese. Say that the mouse is just pushing the piece of cheese straight forward, so we don't have to worry about angles. So f is in the x direction, and it moves the distance x 2 meters. So a mouse is pushing a piece of cheese across the floor, but let's say it's pushing it with a variable force. Say that the mouse is pushing harder and harder as it goes. So maybe the mouse is pushing with a force of 3x, where x is the distance that it's gone at any one point. So this is going to be x final is 2 meters actually. So x initial is 0, x final is 2 meters, and it's pushing a length x across the floor. An arbitrary function. So the work done by the mouse is the integral of the magnitude of the force, 3x, times the magnitude of the displacement, x. I'm sorry, but it is that was for a constant force. Oops. Magnitude. So it's f dot ds. Let me try again. F dot ds is the magnitude of f times the magnitude of ds times the cosine of the angle between f and s. S is the displacement. In this case, in this particular case, s is in the x direction. So ds is equal to dx, because that's just the direction I chose. I could have made all of these s's, right? ds is dx. So therefore, the work done by the force is the magnitude of the force, 3x, times dx, because s is x, our displacement variable is x, and the angle theta, force is in that direction, x is in that direction, so the angle theta is 0 degrees. I was about to say the wrong thing, which is cosine 0 is 1. So it's a constant angle, so it doesn't actually impact it at all, right? So therefore, the work is 3x dx. And we're starting from a x of 0, and we're finishing at an x of 2 meters. So we have to be able to do this integral. We can pull the constants out, 3, 0 to 2 meters, times x dx. And you have to know how to do that integral, x dx. And it's 3 times x squared over 2, evaluated from 0 to 2 meters. And therefore, the units are a little funny here. I wasn't careful. But it is, if we plug in 2, leave my units out, we get 4, 12, 6. 6 joules. The issue was with the units is when I say F is equal to 3x, that has to be in newtons if this is all going to work out. Or I should have said what units that was in. So it would actually be, the 3 itself has units, which I didn't write in this equation. I didn't write that here, right? The 3 has units. Because in order for the force to turn out to be newtons, if x is in meters, which it is in this case, if x is in meters, then this must be newtons per meter, so that the meters of the x cancels with the meters in the newtons per meter and gives us a force of newtons. So if I wanted to carry units through here, which I really didn't, it would have been okay. I would have been okay if you didn't. I should have said newtons per meter is my units here, and newtons per meter is my units here, so that when I get meters, when I plug in meters here and it gets squared, I'm going to end up getting 6 newtons per meter times 2 meters squared. Whoops, I said that wrong. Sorry, that was completely wrong. 3 newtons per meter times 2 meters squared, which is 4 meters squared, over 2, and that gives us 6 joules. The units work out then. Okay. Variable force.